Hi guys, we have this question with us. Let's see how we can break it down. So the question reads, a small sphere of mass m attached to one end of a massless thread. So the other end is fixed to the roof of a truck when it is at rest. So what is the angle, or what angle does a thread make with the vertical when the truck has a constant acceleration of 1.5? Okay. So to be able to easily answer this question, let's break down what we've been given. So we have this thread which is attached in a car or in a truck. So once it starts moving, you will find that the thread will be hanging like this. So because of motion, the thread will hang like this. Then this thread, since it's a thread, meaning that it will have tension in this direction, we'll call this T. So if that's the case, we need to find the two components of this thread. The two components of this thread is of course the x-axis, so the component in the x-axis, and the component in the y-axis, like this. So these two components are represented by the following. Forces acting on this object in the y, we know that this is Ty. Now, tension in the y, since it's the opposite, the angle of interest will be this one here, like this. So this here is T in the x. So since this is opposite to the angle, this will be our T sine. And this is the angle that we're looking for. This one is adjacent to the angle. So this is T cos, like that. Then on top of that, what else do we have? On this object, we have mg acting in this direction, like that. So to easily find the angle, we're going to sum the forces in the x, we're going to sum the forces in the y. To do that, we're going to start with the y. So summation of forces in the y, in this case, will be equals to 0. Why are we saying 0? Because we are making an assumption to say this object is just moving in the x. So in the y, how many forces do we have in the y? We have Ty pointing upwards and mg pointing downwards. So the force which is pointing up will be positive. So Ty positive. The force pointing downwards will be negative. So minus mg is equals to 0, like that. Then from there now, we're going to say Ty is equals to mg. Just made Ty the subject of the formula. Then from there, we're going to sum the forces in the x. This is equals to mass times acceleration, because we're saying that the motion is in the x. So in the x-axis, how many forces do we have? We just have one force, which is this one, pointing to the right. Hence, Tx is equals to ma. So in the x-axis, we have Tx, which is equals to ma. So here it is Tx. Remember, Tx is T sine. So we have T sine theta is equals to ma. Here we have Ty. This is T cos theta is equals to mg. Let's call this equation 1, and let's call this equation 2. So how can we combine the two to find the angle of interest? So let me just rewrite them here. So T cos theta, we said, is equals to mg, and T sine theta is equals to ma. So for both cases, we're going to make, let's start with the first one. Let's make T the subject. So T is equals to mg over cos. So this subject that we've made from this equation, we'll substitute it there. So that here where there is T, we'll have mg over cos multiplied by sine. This is equals to ma. We can write this as mg sine over cos. This is equals to ma. Trigonometry. Sine over cos is equals to tan. So this is an identity from trigonometry mathematics. So here where we have sine over cos, we'll just replace it with a tan. So that mg tan theta is equals to ma. We divide both sides by mass cancels. So what we're looking for in this case is theta. Hence tan theta is equals to a over g. So theta is equals to the tan inverse of a over g. Let's go back to a question. What is a? 1.5. So to find theta, we shall say theta is equals to tan inverse of 1.5 over g, which is 9.81. So theta, the tan inverse of this, will get 8.7 degrees. So that's our angle of interest.